Great, thank you, Alex, for the introduction, and thank you all for being here for what is admittedly a pretty niche topic, but I know there are a few historic aerial photography enthusiasts in the audience. I'm going to share with you work that I've been doing for several years now, but before we get to that, to make sure we're all on the same page as to what is a historic aerial photograph. By definition, there are photos that were captured from the air, from airplanes, on physical film. That's the part that makes them historic, or sometimes called archival aerial photos. They formed the building blocks of cartographic base mapping for decades, nearly a century, starting with systematic collection by the US federal government in the 1930s and extending into the early 2000s. And they were all vertical photography, which means that they were captured in a way that was originally intended to support accurate mapping and measurement. That said, outside of the federal government, there have been lots of aerial photography missions performed by a variety of individuals for different objectives. So not all photos are, historic aerial photos are exactly the same. There are lots of contemporary uses for these photos, academic and non-academic uses, but they all either require or would benefit from them being processed from this physical form into a digital form and combined into imagery layers that we're accustomed to working with in the modern kind of computing environment. So the add data button is all powerful here, and really the goal of this work is to make this resource as easily accessible to you all and others as possible. When that's accomplished, you get something like this. We're here at the red arrow on the banks of the Monongahela in Pittsburgh. And in the foreground, in the black and white photo, is what this landscape looked like in 1993, about 30 years ago, as compared to the present day. And I hope that it's obvious kind of the power or the unique information proposition that this resource offers. You can easily see land development projects that have happened over the last 30 years. And what jumped out at me was the shifting landscape of sports arenas in Pittsburgh. I'm not a Pittsburgh historian, but lots of stadiums have kind of come and gone over the last 30 years. And in case there's anybody that still isn't convinced that this isn't a unique information resource, here's the alternative for this time period. This was the only cloud-free Landsat image I could find in USGS's archive of the same area, the same time period, and it's clearly a different beast. So there's no single life cycle that represents all historic aerial photos, but they generally tend to fall along these two pathways. They all originate as physical film, sometimes following the top pathway. Sometimes that film was preserved in kind of highly controlled archives, are scanned on photogrammetric scanners, and then come to me to kind of work with and process. Other times the film was printed on paper, large format prints, and distributed to people for use. Some of those photos went out in the field, they got rained on, they got brought back and put in filing cabinets, and kind of fast forward to the present day, and we're scanning these on desktop scanners, which are not of the same quality as the photogrammetric scanners. And then they come to me for work and processing. But in reality, so the top is kind of the ideal situation, the bottom pathway is not as ideal. In reality, every new collection exists on a continuum between this ideal and not as ideal life cycle. So my working kind of research question or problem statement is, how do we efficiently, and emphasis on efficient, take this resource from physical collections to this kind of modern expectation of accurately georeferenced and distortion-corrected imagery data sets? And the need for efficiency has to do with the size of these collections. Considering only a single archive from the US Department of Agriculture that houses almost 11 million photos, We have access to, small armies of undergrads who know how to two-dimensionally georeference images in ArcPro, but even that, to do a reasonable job, and just considering this single archive would take, a long time. It's just not, it's not that it's inconvenient, it's not feasible. So fortunately, as I mentioned earlier, many of these photos were captured in a way that was originally meant to support accurate mapping and measurement. And the way that, that they were captured, it was to support this photogrammetry workflow that removed distortions and stitched them together and did all this stuff. And fortunately, this workflow has been incorporated into modern software packages, and even more recently, computer vision techniques have been incorporated into those software workflows that save a lot of time and labor. So at the first step and the second step and the third step, their computer vision techniques have been incorporated into these tools as labor-saving devices, and they work pretty well. However, the one step that they have not been incorporated or can't be incorporated is in this step of identifying ground control points that relate the photos to a contemporary reference base map. This same challenge as with kind of 2D georeferencing. This is fairly recent, within the last 3 or so years, that these tools have become more readily available. And some research has been done on how well they work on film photography. Myself and colleagues tested 3 different software tools on an ideal collection, a small collection of these that represent the ideal case of film that had been scanned on photogrammetric scanners. And we found that using one ground control point per photo produced really impressive results. So that was encouraging. Other researchers at the University of Connecticut have worked with a less ideal case of photos and found that something between 1.5 and 3 ground control points per photo produced, again, reasonable results. But because effort is so important here, I'm going to reference kind of the number of ground control points required per photo as a kind of test of how much promise these approaches have for processing entire collections of historic aerial photos. So based on my experience with these different tools and how they work a little bit differently. I proposed kind of alternative workflows for collections that either are more ideal or less ideal. And so if the photos come to us with a known camera focal length and fiducial marks, which are kind of these marks on the edges of the photos that can be detected by those computer vision techniques, I'm kind of funneling those into more of an engineering type tool. In this case, it's deployed in ArcPro, but it's deployed in other software packages as well. So we're kind of imposing numbers on these photos because we think that we know them. And then for photos that don't have, that just come to us without a known, camera or we really don't know much of anything about them. We're using a different tool that takes a more of an empirical approach and kind of does its magic just based on what it can learn. So in trying to kind of test these alternative workflows, I really just felt like I needed to start processing collections. And so I worked with 10 collections all from Pennsylvania. They were as old as from the late 1940s up through the early 2000s. Collectively, they represented more than 1,750 photos. They were all black and white. They all followed some form of that kind of not ideal pathway of prints that were scanned on desktop scanners. And my goals, again, in making this resource useful to a broad audience was that I produce 1 meter seamless orthomosaics that were kind of in that 5 to 10 meter horizontal positional accuracy, basically the kind of specifications that we're accustomed to and with modern imagery data sets. The results were that I was able to do that for all 10 collections. Together, they cover over 2,000 square miles of Pennsylvania. I was aiming for kind of 30 ground control points per collection, even though the size of the collections varied, but to kind of get a variation in effort level and hopefully learn something about how well these methods work. And for that horizontal positional accuracy part, I achieved my goal of less than 10 meter accuracy in half of the collections. Some of them turned out much better, and some of them turned out much worse. And I was interested in learning or understanding more about why that is. And there are aspects of these workflows that we kind of know have an impact on the results. And one of them is in deploying the computer vision technique that does the relative orientation of kind of stitching these photos together. It works on key point matching that works a lot better in urban environments where you have high dark and light image contrast on gridded streets, for example, that have like hard edges. So that works a lot better, and it turns out that with these kinds of collections, it influences the results. All of my collections that I was working with that depicted urban environments kind of met my goals. Other places to look were, which of those two pathways or alternative workflows I was using, which tools I was using. And so this is the bottom left graphic, and there were arguably differences, but not kind of consistent differences between the two softwares that I was using. What I've called the engineering approach produced more consistent results, but they weren't actually that good. They didn't meet my kind of my goals. And then perhaps most importantly was the effort that I put into each collection on a per photo basis. And this is the graphic on the upper right. I had expected that the more ground control points that I used per photo, the better results that I would get. I mean, that's kind of that's how we understand the process to work. But there's not a lot of pattern in this graphic. So that's a little confusing. And then finally, for those 5 collections that didn't meet my goals, other evidence that kind of those are the appropriate goals is when they didn't meet that roughly 10 meter horizontal positional accuracy threshold, other issues surfaced. And those are misalignment of linear features across seam lines where the photos meet, as well as things like double imaging where a single feature that's depicted in 2 different photos, they're spatially disjointed from each other, and so when you mosaic them together, they become 2 separate features when they're only supposed to be one. And this is the bottom graphic there. So I have kind of more questions than answers as a result of this. I mean, I think that probably working with 10 collections, as much effort as that was, maybe isn't enough to learn about how we should approach this problem. I mean, I still think that we need rules or kind of, alternative workflows to use on these collections, but it also made me realize how diverse they are, and we often don't understand a lot about their provenance of where they came from. So I'm not sure. I think that we need rules. I'm not sure if we can ever get there. And then it also, realizing how unstructured this resource is made me question whether this traditional workflow that was kind of developed for ideal cases of working with the original film, whether that's even the right approach, or whether we should be considering new tools that do better with kind of more unstructured data. So I've been working on this for a while. I've had lots of help and from students and colleagues and people in the software industry, and I couldn't have done this without them. I want to recognize them here on this slide. These are the references if anybody's interested, and I think I have time for a question or two. Thank you for your attention.
Thank you, Nathan. We do have time for some questions, so please, if you have any questions about Nathan's work with the aerial photos.
Yeah.
To create the seamless orthomosaic, did the photos have like information collars on them that you had to clip out, or did you have an automated way to do that?
Yes. The question was, to create the seamless mosaics, did I have to clip out like margins, basically? And the answer is yes. I mean, given the time constraints, I couldn't go into like all the details, but yes, they have margins that they tend to have margins on them, and you're only trying to consider what's within the fiducial markings. And that is one of the computer vision techniques, uses template matching to automatically identify those fiducials rather than you having to like click on every one of them. And it works pretty well. Yeah.
So, another question in the back?
Yeah, great presentation.
Thank you.
Is there a lot of temporal overlap between, in an area over time? I just remember my grandfather was a farmer, and then when he retired back in Kansas, he would get those NRCS images and go out in the field and spot check crops and stuff. And there must be tons of images actually over the same area.
Yes, that's a great question that I wish I better knew the answer to. The federal programs were roughly 10-year revisit intervals. So for that 80-year period, we tend to have it's nearly wall-to-wall coverage in the continental U.S. Usually about 8 times. What I don't know the answer to is that for a lot of places, there's so many more photos out there, and they're in disparate collections, and nobody really knows, how many there are. So far, we're just kind of passively receiving these, and I think if you went out and actively sought them out, that you'd find that there's a lot.
I think we have time for one more question.
I have a question about the user demand for these, your user groups. You had a short list, and one of them mentioned law enforcement. I was curious how law enforcement's using a historical archive.
Yeah, thank you for that. I mean, I wish I had time to share more stories. Maybe that would even be more interesting to you all. But we fairly frequently get questions from law enforcement that are investigating cold cases. And I mean, last week I heard rumor that a historic aerial photograph helped them find a crime scene.
Unsolved mysteries.
Yeah.
All right. Thank you, Nathan.
Yeah, thank you.